Hey guys, back with some more scientific notation here. We're going to look at multiplying and dividing in scientific notation. We will be able to multiply numbers expressed in scientific notation and divide scientific notation. So the example we want to get into is about our solar system. Includes 8 planets. Used to be 9 when I was a kid. I guess Pluto doesn't count anymore. But anyways, let's look at some information about the planets and see if we can see how this scientific notation is going to work for us. So number one here, Earth is 93 million miles away from the sun and has an approximate mass of 6, with a ton of zeros there, kilograms. So let's see, can we get these numbers written in scientific notation? Kind of a quick little review here, I guess. So the Earth's distance, okay, is going to be this first number, the 93 million. So to write that in scientific notation, again, we need to find out a number between 1 and 10 to be the factor. So we're going to have to use 9.3. Times 10 to the, and we're going to count the number of digits after the 9 there, because that's where a decimal place would be. So 1, 2, 3, 4, 5, 6, 7. So we're going to have times 10 to the 7th power. Okay, now for the Earth's mass, okay, that's this gigantic number here. Let's see, 1, 2, 3, 4, 5, 6, 7. I'm counting the groups of 3s and 0s. So there's 8 groups of 3s with zeros, right? After that 6, I'm just trying to get a shortcut instead of counting every single 0. So I believe there's 24 zeros there. So we would be able to write this as 6. Okay, after the 6, again, there are 24 zeros. So times 10 to the 24th power. So definitely something you want to do in scientific notation instead of having to write 24 zeros there, right? All right, so that should be a little review of scientific notation. Let's move ahead. So Earth moves at approximate average speed of 107,000 kilometers per hour. Okay, so pretty fast. It takes Earth approximately 8,800 hours to orbit the sun. So using these numbers, can we find the approximate distance the Earth travels when orbiting the sun? So if it's 107,000, and I'm going to write this as kind of a fraction just so we can see what's going on, kilometers per hour. Okay, that's the average speed. And if we are going that speed for 8,800 hours, okay, if we multiply those numbers together, okay, and this might be a little bit advanced or something you might get into in a science class down the road, but what actually ends up happening, we could think of there being a 1 under here, but the units can actually kind of cancel each other out as well. If you have hours up here and then hours down here, this is kind of called dimensional analysis. They're just using different units. But basically our final answer, since the hours cancel out, our answer is going to be in kilometers, which is what we want to do. So I'm just going to multiply the 107,000 times 8,800 on a calculator there. And I'm getting this gigantic answer of 9416, and then there's 1, 2, 3, 4, 5 zeros. And that's going to be a distance, right? That's the distance the Earth would travel. Okay, again, if it's going 107,000 kilometers per hour for that many hours, if we multiply them, it should give us a distance traveled. Okay, so a lot of kilometers. All right, so part B, can we express the average speed of Earth in scientific notation? Okay, so just this number here, in scientific notation, again, it's 107,000, so we would need it to be 1.07. Decimal would have to go in between the 1 and the 0 there to make our factor between 1 and 10. And then if I'm counting digits after the decimal point is 1, 2, 3, 4, 5, so we're going to be multiplying by times 10 to the 5th power. And again, that's going to be kilometers per hour. Okay, let's see, what else do they want us to do? Express the total amount of hours it takes in scientific notation. So this 8,800 in scientific notation, again, it would have to be 8.8 times 10 to the, if the decimal was between the 8s, it'd be times 10 to the 3rd. Okay, and now write our answer to part A in scientific notation as well. Okay, so our answer to part A was this big number over here, right? So if we want to do that in scientific notation, we would need to write it as 9.416 times 10 to the, and let's see, if the decimal were there, there's how many digits after? 1, 2, 3, 4, 5, 6, 7, 8. times 10 to the 8th power. Okay, so let's see if we can make a connection here. So that's the answer that we got when we just multiplied the standard forms together, right? Okay, so take a look. What we were really doing was multiplying the average speed multiplied by the number of hours, right? And that's what we did in part A. Okay, and the answer written in scientific notation looks like that. Okay, let's take a look back and let's go to each of these values in scientific notation. Okay, the average speed, this is what part B was asking about. In scientific notation, it's 1.07 times 10 to the 5th. Okay, and the amount of hours was 8.8 times 10 to the 3rd. Okay, that's what we did in part C. Okay, and if we were to multiply these together, it looks like we were going to get this gigantic number up here, right? Which in scientific notation is this 9.416 number times 10 to the 8th. So what I want you guys to take a look at, if we were to multiply the 1.07 times 8.8, okay, that would actually equal the 9.416. Okay, and if we were to multiply the 10 to the 5th times 10 to the 3rd, okay, remember our rules of exponents in the previous chapter? It said we can add those exponents. That would actually multiply to be 10 to the 8th. So what we're allowed to do with scientific notation, okay, and this is really just the commutative or the associative property. When you multiply a bunch of things together, okay, let me just rewrite this. We were really just doing 1.07 times 10 to the 5th times 8.8 times 10 to the 3rd, right? We were just multiplying all those numbers together. So what I'm saying is you can multiply, just like with addition, you could do it in any order you want. So we could first multiply this times this, which we did. Okay, that ends up equaling this. And then when you multiply 10 to the 5th and 10 to the 3rd, it ends up equaling this. Okay, so you're able to do that when you multiply two numbers in scientific notation. Okay, let's look at a couple other examples though. All right, so let's do the next page here, and let's do a couple. Try these. Let's do some of it on our own. Number 2 up here. Can we simplify each expression and write our answer in scientific notation? Okay, so the deal is we can multiply, again, the 9 times the 3 first to get 27. And then when we do multiply the 10 to the 5th times 10 to the 4th, remember, you're just adding exponents. Okay, it's from the previous lesson right there. That's going to end up equaling 10 to the 9th. Now, here's our little trick, though. Is this scientific notation? And the answer is it's not yet scientific notation because 27 is not between 1 and 10. So it would need to be written as 2.7. Okay, so we actually had to move the decimal one place back. So that means that on the 10 to the power, we're going to need to increase that and kind of add that we moved it back, move it back one more time that way to make it times 10 to the 10th. Okay, just to show a little more detail on that step, again, we had it originally as 27 times 10 to the 9th, right, which means 27 with 9 zeros. Okay, but to correctly write scientific notation, again, it can't be 27. It would need to be 2.7. So this same number right here in scientific notation would be 2.7. And now there are 10 digits after the decimal place. Okay, so that's why my exponent here became a 10. Okay, let's do a couple other examples though. Let's see what we got going on in part C there. Okay, part C, we want to multiply first. We're just going to multiply the factor, the let me highlight here, the 1.6 times 3. Okay, so 1.6 times 3 should be 4.8. Okay, and then times, we're going to, again, it's 10 to the 8th and 10 to the 4th, so we're just going to add those exponents and make that times 10 to the 12th. Okay, that one's good to go. 4.8 is in between 1 and 10, so we don't have to do any adjustments at all. Okay, and the last one, If we multiply the 4 times the 6, okay, that's going to get me, of course, 24. And then if we just add exponents on the 10 to the 12th and 10 to the 5th, we are going to get 10 to the 17th. Okay, but again, that one's not scientific notation yet because 24 is not between 1 and 10, so we would need to rewrite it as 2.4. Okay, and since we needed to change it, the decimal place moved 1 back to go 2.4, we need to add that 1 digit back to the exponent. So this would be 2.4 times 10 to the 18th power. All right, you can actually do some of this stuff in scientific notation on certain calculators. So what you want to look for example, to do this one here, like we did first above, certain calculators have like an EE button, or maybe just an E. I know on the graphing calculators, it's kind of it's a button above the 7. But what you can do to multiply these things, you can write this as 9, and then hit that button. It will say EE, and then you can put 5, and that will let you know that it's actually it only writes 1 E. I just tested it on my calculator, but that will let you know that you're talking in scientific notation. Okay, so this is equivalent to seeing this on your calculator. And if you do the other one, if you multiply that by 3 and do the same button, E to the 4th, it will actually end up giving you an answer as 2.7 E 10. And you can see that was the answer, 2.7 times 10 to the 10th. Okay, and that's just optional. You know, you don't have to know how to do it on the calculator, but if you're looking around, you can Google your specific calculator and kind of see how that works, or maybe a YouTube video on that. But since it's not required, I'm not going to spend any extra time on the calculator steps. But just know it is out there. It can be done. All right, let's jump back into our solar system example series. Are kind of cool. So Jupiter is the largest planet with the mass of that gigantic number. And Mercury is the smallest planet, okay, with a mass of pretty big number itself, but clearly not as big, not as many zeros as Jupiter. Okay, so using the numbers that are written in standard form, determine how many times as large Jupiter is than Mercury. So I'm going to see, can I even fit this in my calculator? So I'm entering a bunch of zeros. Okay, and on the graphing calculators, you can do it. Certain calculators, you cannot do it. They just don't have enough room. So scientific notation is going to really be the way to go. But what I'm really doing, just so you know what I'm doing, I'm entering this 1,900,800, all that, and I'm going to divide it by the smaller number of Mercury's mass. And when I divide these, it will tell me how many times as large Jupiter is than Mercury. And I did that on my calculator. I ended up with 5,760. Okay, so Jupiter is 5,760 times larger than Mercury is based on mass. Okay, so if your calculator can fit that, you can do it that way. If not, and if you don't feel like typing in all those zeros, okay, scientific notation is going to be the way to go. So let's see if we can get each of these numbers in scientific notation and then kind of divide them that way. So Jupiter's mass, okay, this gigantic number here, okay, I kind of did the counting already. It's 1.9008. It's times 10 to the 27th power. Okay, really, really big number. Mercury's mass is 3.3 times 10 to the 23rd power. Okay, now what I want to do, let's do one thing. Let's write our answer that we got in part A in scientific notation. Okay, so 5,760 would end up being, as a number between 1 and 10, would have to be 5.76. And we had moved the decimal 3 times to get it out here where it needs to be. Okay, so times 10 to the 3rd. So let's see, can we see how using the numbers written in scientific notation, okay, how could we figure out this answer to part A using scientific notation? So let's try this. Let's divide in scientific notation 1.9008 times 10 to the 27th power, right? That's Jupiter's mass, divided by Mercury's mass, 3.3 times 10 to the 23rd. And let's see what we get, okay? I'm going to just do it very similarly to how we did the multiplication. Okay, I'm going to divide this by this, okay, on my calculator, 1.9008, and I'm going to divide by 3.3. okay, and that's giving me 0.576. Okay, and then with the 10 to the powers, okay, remember we do this by, when you divide with the same base, you actually subtract exponents, correct? So this would be times 10. If we do the 27 minus 23, it would be 10 to the 4th power. Okay, now is that answer in scientific notation? And the answer is no here, right? It's not yet, because that base, or the factor, I should say, the 0.576, is not between 1 and 10. So it would need to be 5.76. Okay, so the decimal needed to be here. Okay, it's really here. Okay, so we would need to take away 1 from the exponent on the 10 and make it 5.76 times 10 to the 3rd. Okay, another way to kind of verify that, let me just take this number up here where we have a little space. 0.576 times 10 to the 4th in standard form, okay, would end up being moving the decimal 4 places to the right, so 1, 2, 3, 4, so it would be right there. It would be 5,760. So hopefully we can make the connection how that ends up being 5.76 times 10 to the 3rd power. Okay, so sometimes if you want to just go back to standard form, you can, to make those, when you need to make the adjustments like that. Now what I want you guys to notice, this answer is equal to the answer we got when we came up here and we divided in standard form. So we did do that correctly. Okay, let's do a couple more examples and finish this up. All right, let's simplify each of these and write our answer in scientific notation. Okay, so what I'm going to do, let me just spell out exactly what we're going to do. We're going to end up doing the 16.4 divided by 4.1, and then I'm going to do times 10 to the 9th over 10 to the 5th. So I'm kind of just treating it as division problems, and I'm just like we did before, I'm going to divide the factor part and then separately divide the 10 to the power part. Okay, so let's see what we get. So when we do the calculations, the 16.4 divided by 4.1, that does equal 4. Okay, and the 10 to the 9th divided by 10 to the 5th, remember we subtract exponents there, so 9 minus 5 becomes 4, so times 10 to the 4th. Okay, what about part B? 2 divided by 8 times 10 to the 8th over 10 to the 2nd. Okay, the 2 divided by 8 is actually 0.25. Okay, it's 1/4. And subtracting the exponents on the 10s, right? 10 to the 8 minus 2, or 10 to the 6th. Now this one we do need to adjust a little bit because our factor of 0.25 is not between 1 and 10. So if you want, you can always change it to standard form, right? We're going to move the decimal place 6 times to the right. So 1, 2, 3, 4, 5, 6. So you would have 4 zeros there. Okay, so to get that again into scientific notation, the decimal place should be between the 2 and the 5. It should be 2.5. And we can simply count the 1, 2, 3, 4, 5 digits after the decimal. So scientific notation, the correct answer for part B would be 2.5 times 10 to the 5th power. All right, and one last one. Let's do part C here. If we want to take 5.1, oops, let me get the pencil back. 5.5, divided by 1.1 times 10 squared over 10 to the 4th. And when we do our division here, okay, the 5.5 divided by 1.1 is just 5. 10 to the 2nd over 10 to the 4th. You can subtract exponents. It's 10 to the negative 2nd power. Okay. Now, normally it's not acceptable to leave things with a negative exponent, but scientific notation is one of those times when it's actually okay. And our factor 5 is between 1 and 10, so that would be perfectly fine for scientific notation.